Hi, and welcome to this video on area of trapeziums, kites, and parallelograms. So, first of all, let's just talk about what we can see here. What type of shapes are these? And I've been a bit naughty because I haven't put any parallel lines on, but you can assume that these are parallel, these ones are parallel. Sorry about my arrows, I'm just doing this quickly. They're all parallel. So have a little think, maybe pause the video. Okay, well, this one is called a trapezium. Trapezium. The very first one, you could argue that this is called a rhombus. And, oh, don't know what happened there. That's a U. But the thing is a trapezium has one set of parallel lines, and a parallelogram, or a rhombus, so this one being if I do that, this would be a parallelogram. And a parallelogram is the same shape really as a rhombus, but a rhombus is a special parallelogram because all the sides are the same length. A rectangle is also a parallelogram. We're going to talk about that in a bit more detail in a minute, but it's just a special parallelogram, even more so because all the sides are the same. And then we have a square, which is also a parallelogram. It's also a rectangle, just an even more special one because all the sides are the same and all the angles are the same, so it has another special name. But this is a trapezium, this is a trapezium, and this is also a trapezium. Now, this one you could call it an isosceles trapezium. You could call this first one a right angle trapezium, and these aren't special enough to have another name. This one at the bottom here, this is the one that most people have no idea what it is, but it is a trapezium. It just looks a bit funny. So, with that in mind, the area of a triangle we should know is half times base times height. That's from a previous lesson. Now we're going to have a look at the area of a trapezium. But hang on, I've drawn a triangle. Don't worry, I did that deliberately. Because if you chop the top of a triangle off and we get rid of it, you actually get a trapezium. Now, let's go back to the triangle. That's the base, and we call the perpendicular height the height of the trapezium. Well, guess what? That's still my base, and that perpendicular height to the base is still what we need. But it can't be half base times height because it's not a triangle, and now we've got this extra side. We can't just surely ignore that side, and we don't. We decided to call that A because it's very close to the letter B, I guess. And what's happened? When we make a trapezium, we've added in this extra side. So what we do is we just add in the extra side. So A plus B stands for the sum of the parallel sides. So A plus B is the sum of the parallel sides. If you YouTube the area of trapezium, there's a very cheesy video, great for learning it, to Pop Goes the Weasel, for this formula. So just YouTube that, it will never leave your head and you'll always remember it. So I should write A equals here in front of both of these. Area equals. So we're going to use that formula, and we're going to look at some tricks like we did in the area of triangles and how to use it more efficiently. So this first one kind of looks like an isosceles trapezium. The marks aren't there, so it may not be, but we're going to just treat it as a normal trapezium. So let's write the formula. Area equals half, open bracket, sum of the parallel sides times the height. It doesn't matter which one's A and which one's B, but we tend to call the base B for base, and the other one A. That'd be my height. So, oops, sorry about that. So let's go half 4 plus 10 times 6. Now, I didn't put a times there, so I can, if that makes you happy, and I could put a times here as well. Which is basically saying half times 14 times 6. Well, crikey, 14 times 6. I don't want to do that. I don't have to do that because I don't have to half 14 times 6. I could half 14 and then times that answer by 6. That's 7 times 6, so that's 42. That's definitely the easiest option. I could half 6 to get 3. 3 times 14, that's not that easy, but that's also 42. 14 times 6, if you're wondering, is 84. Half of 84 is 42. So just choose the easiest path. Remember, because of BIDMAS, we can do the multiplication in any order we like. Really useful. Let's do the same for this one. So this is now a right angle trapezium, and I should really have put these marks on, but I did tell you it was a trapezium, so I don't need to put those on. With two right angles, it means it's definitely a trapezium. So once again, I'm going to write the formula out. All good mathematicians write the formula every single time. You could skip this bit. You could just go for 16. You could skip that working stage here. I'm happy with that. And then we've got times 8. Now, what's this fella doing? He's just there to put you off. This is like a slanted length. It's got nothing to do with my formula, so I don't use it. Again, 16 times 8. I don't know what that is, but I do know what half 16 is. That's 8. And 8 times 8 is 64. I could have done half times 8, 4. 4 times 16. But the easiest path was to do half 16 first. Now, we try and trick you sometimes, but this is a trapezium. They'll either tell you it's a trapezium or they'll put those on. So let's do this one. I always write the formula. That's the bit I never skip. So what are my parallel sides? Okay, so 12 and 7, that's 19. Ugh, not nice. Times the height, which is 4. Okay, 19 fours, that's pretty easy. I'm still not going to do it because I'd rather do half of 4 is 2 and do 19 twos. Nice and simple. I definitely wouldn't half 19 and times that by 4. It's just more difficult. Okay, another trapezium, but this time you can see it's just been rotated. So I've got half, and what are my parallel sides? Well, this is not the base. Remember, the a plus b represents the two parallel sides, so that would be the base, or that would be a. And this is why using the word base doesn't make any sense now, because that's clearly the base. It's just the sum of the parallel sides. And what is the sum? Well, that's 9. And we're timesing that by the height, which is 5. So here's the height in this instance. Okay, half 9. Can't do that really. Half 5. No. I'm going to just do 9 5s are 45. And you could leave it like that. Or you could go to 22.5 centimeters squared. Let's look at some more shapes. So here's a kite. This is not a diamond. A diamond is a three-dimensional object. People call rhombuses diamonds, kites diamonds. We can't do that anymore. But what you should be able to see, if I drew a line down here, I make this shape here. So I could simply find the area of the triangle and then multiply it by 2. And for that, I know this is 2. And I know this is 12. So I could say, right, area is half base times height. I've got the perpendicular height to the base, easy peasy. I'm going to do 6 times 2 is 12. I could have cancelled these off. So therefore, the area of the kite must be 24 centimeters squared. Okay, well, that's all well and good, but we needed a quicker way. So you can see what we're doing here is finding the area of one kite and then multiplying it by 2. So technically, if I multiply it by 2, what I'm getting rid of is this, and I've got base times height. But if I do base times height, you can see that's wrong. 4 times 12 doesn't equal 24. And that's because 12 times 2 equals 24. So that's actually what we're doing. So where's the 12? Well, 12 is there. And where's the 2 come from? Ah, well, it's that bit there. And how do we get that? Well, we halve this figure here. So what we decided to do, very similar to the trapezium, if we call this A, and this one, oh sorry, I didn't mean to cross that out, silly me. Call this one B. What we're actually doing is the area of a kite is just half AB. AB just represents dimensions, so it's half times 4 times 12. That's 24. It's just a bit quicker than doing the two triangles, but if you forget it, then you can just do the triangles. It's not a problem. Let's have a look at another one. So we know the area is half AB. So it's half, they're the two dimensions, 5 times 10. Half and 50 is pretty easy. Half 10, 5, 5 fives. It doesn't matter what you do, but it's just 25 centimeters squared. Now, one more shape to talk about, and that is the parallelogram. A parallelogram is just a rectangle, and I'm sure you all know it's length times width, that being length, that being width. Parallelogram, we just don't use those letters. We go back to B for base, and like the width is actually perpendicular height, so I could call that height if I wanted to. And it's the same shape. It's just a special version, so the area is just the same. So it's just base times height. And if you think about it, if I just drew a line down here, this triangle, I could just pick it up, I could move it to here, and I'd have a rectangle. So if I got rid of that and put it there, you can see it's a rectangle. That's why it's the same formula. So just time for you now to go ahead and practice. Best of luck, everyone.